these are the notes for 8.1. This is the second set of notes. So this is our part 2. In the first part, we talked about if I give you a sequence or a rule that you find me the first 6 terms. And now I'm going to give you the terms and I want you to describe the pattern, write the next term, and find that rule that will work for any term in the sequence. So if someone were to say, okay, what's the 50th term, you could actually figure it out. So let's start with number 1. All right, my sequence is 3, 5, 7, 9, and it keeps going from there. So we need to look at what is happening each time to figure out our pattern. Well, from 3 to 5, I added 2. From 5 to 7, you add 2. And from 7, you add 2. So to find that next term, I know I just need to add 2. So my next term is going to be 11. Okay, that's that a fifth. That equals a to the little sub 5 there, because that's my 5th term. But now we need our rule. So, well, for describing the pattern, you could write down it's adding 2 to each term to get to the next term. But to find our pattern, if you remember, we had, last time, if this is n, and this was an, and remember, n is just where that term is. And here we have 4 terms. It gave us 4 terms. And it gave us 5, started with 3, 5, 7, 9. Okay. And we need to look at like the changes that are happening on each n and an. So for n, it's adding 1 each time to get to the next term, obviously, because we're going in order. It's term 1, term 2, term 3, term 4. And on the bottom, it added 2. So this actually takes us back to when we talked about linear functions. When both x and y's changes are constant, we have a linear function. So if we have a linear function, we know a linear function equation looks like this. And our n is in our x spot. So like this is x, okay? And we're looking at the changes that happen. So our slope is always y over x. So in this case, it's going to be, the an over n, which our change was 2. It goes up 2 on the bottom, and on the top it goes up 1. So that is kind of our slope. So I'm thinking, okay, if I multiply n by 2 each time, what happens? So let's find if n is, so a1, so this is my first term. So if n is 1, let's take 2 times 1. Well, I get 2, but the number it gives me is 3. So to get to the 3, I just need to add 1 more. Let's do that in a different color, make it a little more clear. Okay, well, let's try another one. So a2, I know I'm multiplying by 2 because I said that was my slope, and this turns out to be linear. Well, I get 4, but the term it gives me is 5. So I need to add 1 more to get 5. And I want to make sure this pattern holds true. So for the third term, 2 times 3 is 6, but the term it gave me right here is 7, so I add 1. And then that fourth term it gave me, so I'm plugging in 4 for n, it gives me 9, but 2 times 4 is 8, so again I had to add 1. Okay, so if you notice, this column, next to the 2, is all that's changing. So if I write my rule for an, any term, I'm going to take it times 2, times whatever that term number is, and I'm going to add 1 to it. Okay, so this is the rule we come up with. So when you found that you were just adding 2 here, just adding 2 every time, you're going to take n and you're going to multiply it by that number. The only question is then, what is the plus or minus depending on what that first term is? And then that kind of helps you find that rule when you have a linear equation. All right, let's move over to number 2. All right, we want to figure out what our sequence is doing here, describe how it gets the next term, find that next term, and then state its rule. Well, if I look here, okay, so that adds 5, that adds 7, that adds 9. you should see that pattern. It should add 11 to get to the next term. So my fifth term is going to be what, 25? No, 35. Okay. And you could say, okay, it's adding the next odd number to get to the next term. What you see in the pattern might change or might be different. It's okay. Everyone sees these patterns just a little bit differently. But I like to do the T-chart. To me, it helps me organize my thoughts here. We have 4 terms, 3, 8, 15, and 24. That's what was given to us. And I know, because this is not constant this time, I know it cannot be linear. But if I look at it again and I like, oh, well, the difference between 5 and 7 is 2, and 7 and 9 is 2, and 9 and 11 is 2, that next row being the same means this is actually quadratic. So the first one, when the first line is all the same, when it's adding or subtracting by a certain number, it's always linear. When that is not true, you check the next line. You check those differences and see if you get everything the same. And this time we did. So we're going to say this is actually a quadratic, which means now something is squared. And usually we square x, but in this case we're using the term n. So I'm actually going to add another row up here just to look. I'm going to add n squared. Well, if n is 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And I want to see how these can get me to my terms. Okay. Well, if I look, this being a 2 here means I'm going to multiply something by 2. I know that. Okay. And if I do that, and you always multiply it by n here. So 2 times 1. Well, I only get 2. But I know this is also going up because it's quadratic by an n squared. So what if I had n squared plus 2 times 1? Well, that's 1 plus 2 is 3. That actually worked out. So let's try it again. Let's try it with the second term. If n is 2, I'm going to square it. And I'm going to take it times 2. Well, that's 4 plus 4 is 8. That was that next term. All right. 3 squared plus 2 times 3. So 9 plus 6 is 15. There's that term. And then let's see, 4 squared plus 2 times 4. So 16 plus 8 is 24. So all of my terms worked out. I knew it was quadratic, so I knew I had to have n being squared. And then I saw that these differences in my row of differences for the quadratic, the second level down, was going up by 2. So I knew I also had to multiply the n, the number of term, by 2. So that helps me find my rule. Oops, lost my 24 there. So if I write out my rule for an, any nth term, I'm going to take n and I'm going to square it, and then I'm going to add 2 times that n. I do want to say there are more than one way to find these. So this equation could have looked different. Could have been n times n plus 2. It could have been things like that. So if your pattern, the way you're visually seeing this, comes out to a different equation, as long as it works and you can check it for your 4 terms and it works every time, whatever variates, what changes, that is always the variable n. And that's how you'd put it in. So your answer does not have to look like this. There are other correct answers too. All right, let's move on to number 3. Ooh, I've got a lot of dots showing up here. Hold on. All right, so I first have to figure out what's going on. So the previous 2, it was obvious. It was adding each time to get to the next term. We could figure out the terms this way, but this time it doesn't. This time it's taking 1, and it looks to me like it's multiplying by -2. -2 times -2 is 4. 4 times negative 2 is negative 8. So this is not adding. We're not going to have it in quadratic. We're not having linear. We have to kind of figure out what this is. But I do know I'm going to multiply by negative 2 to get to my next term. So my fifth term is going to be a positive 16. Okay, so when it asks you to describe the pattern, you just say, I'm multiplying each term by negative 2 to get to the next term. So again, I like keeping things organized in this little chart, so it always lets me kind of check, because we're going to be plugging these ends in. 1, negative 2, 4, negative 8. Okay, so I know things are going to be multiplying by negative 2 each time, and n is going to go up by 1 every time. So this takes us actually back to, I believe, chapter 6 when we talked about exponentials. If I'm going to take, and it's multiplying by negative 2, so I'm going to say negative 2 is my base. And let's put n up at the top and see what happens, okay? So if I'm trying that, if I say, okay, negative 2 is my base, does have to be in parentheses because that negative is being squared. That's how the sign is changing, okay? It went to positive, negative, okay, that kind of thing. But my first n is 1. Well, if I do that, I actually get negative 2 as my answer. And this, it needs to be a 1. Well, we know if we take anything to the 0 power, we are going to get 1 as our answer. So if we kind of back this up a little bit, I'm plugging in 1, so that's n. And I want it to be 0, so what if I subtract 1? Okay, so now I have negative 2 to the 0 power is 1. Okay, that works for this one. Let's try for the next one. Negative 2. I'm plugging in 2 for n minus 1. So that is, I should put that in parentheses, negative 2 to the 1 power is negative 2. Hey, that works. That got us our second one. Let's try it again. Negative 2, plugging in 3, got to subtract the 1. So that's negative 2 squared is 4. So far, so good. Let's try our last one here. Fourth term. So it's negative 2 cubed, and that is negative 8. So that found it. So our rule, I just needed to put n's in what changes, and that's that term right there. Everything else had a minus 1. So my rule for the nth term became negative 2 to the n minus 1 power. All right, so let's move on to number 4. All right, my terms are 2, 5, 10, 17. Okay, we need to look at this. Doesn't look like I'm multiplying by anything, but let's try adding again. That's always the easiest one to check first. Okay, so I'm adding 3. I'm adding 5. I'm adding 7. Okay, there is a pattern. It's adding the next odd number. So I know I'm going to add 9. So my fifth term is going to be 26. All right, and we talked about this one actually on number 2, where it's not linear because that addition right here is not constant. If it was, we know we'd have a linear function or sequence, but that's not constant. But the next row from 3 to get to 5 was 2, from 5 to 7 adds 2, and from 7 to 9 adds 2. So because the difference of the first set of differences is true, this is quadratic. Okay, so we know we're going to be having 2n somewhere in there, but we have an n squared as well. So if we write down our original terms, we have n's, a to the n power, okay, 3, 4, 2, 5, 10, 17. Okay, so, all right, so we know this is quadratic because the difference of the differences. So I'm going to go ahead and do my n squared row here. And we square n, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. All right, we know we're going to square. We know it's quadratic, so let's start with that. So I'm going to find that first term. I know if I take 1 squared, okay, that's n being squared is 1. Well, I get 1, but I want 2. Well, so let's start off with, let's see if I just add 1 to get to the 2. I know that equals 2, so, okay. Let's try that for the next term. So if I square my second term, I get 4, but I want it to be 5. So I'm going to add 1. Well, that got me 5. So looks like we found our pattern already, but we need to keep going and checking it. So square the third term is 9. I want 10, so I know I'm going to add 1. And you can look at that by here. See, this is 1, 2, 4, 5, 9, 10, 16, 17. Those difference is only 1 each time. So I could tell if this is squared, I only had to add 1 to get to there. So that helps a little. If we do this, we said that's 10. So 4 squared is 16 plus 1 will be 17. Remember, what changes is n when we write it as our rule. So a to the n is n. That's where it changes, being squared, and it adds 1 each time. Okay? So part of this, I know it's a little frustrating, but it is guess and check. Okay, I'm showing you some key hints to help you kind of figure out where to start, like how to figure out that this one was actually quadratic, or number 3 was multiplying, so by 2 each time, so we know it's going to be exponential. But you're going to have to look and see, okay, what am I adding or subtracting or that kind of thing. It is guess and check, and but hopefully you get the hang of it pretty quick. All right, let's look at number 5. Our next term here. All right, our next sequence. Our sequence goes 1, 3.5, 2, 5.5. So let's look at how we go from 1 to 3.5. It looks to me like I'm adding a half. Well, 3.5 to get to 2 is adding a half. I added a half here, so I know I'm going to add a half to get that 5th term, a5, and that's going to be 3. All right, now since our first set of differences is all constant, this is all the same, I know this is linear. But still, the little chart, you know, you don't have to draw this. I just find it helpful to separate out what I need separated to make sure my terms are coming out the same when I'm double checking. Because sometimes up here I'm like, okay, counting which term, because sometimes you'll have more than 4, or you'll have like, well, never mind. We'll get to that other later. I don't want to confuse you now. So I know we're adding a half and it's linear. So I know I'm going to take that 1/2 and I'm going to multiply it by n. So we're going to do the first one. N is 1. But I only get half times 1 is 1/2. And I need it to be 1. So, oops, I don't want equals. I want plus. So if I add another half to it, I get 1. Let's try that with the next one. Second term. Well, 1/2 times 2 is 1, but 3/2 is 1.5. So if I add another half to it, I get 3/2. All right, let's try the third term. Well, that gets me 3/2, but if I add another half to that, I get 2. Oh, except I wrote something wrong. Oops, that wasn't a 3. I said 3 when I was talking about it, but that's a half. So let's try the fourth term. That's 2, but I want 2.5, which is 5/2. So I had to add the half. So my rule for the nth term, I know I'm taking 1/2 times what's changing each time, so n, and then I need to add a half to it. Now again, this could have been seen different. You might have seen, okay, well, I'm taking 1/2 times n plus 1. Okay, it can look different depending on how you're seeing your pattern. All right, let's move on to number 6. All right, so the last one was a fraction one. Now we're going to do a decimal. Let's always start by seeing if we're adding anything. And this adds 7.8. That's also 7.8 to get to the next term. So I'm going to add 7.8 to get to my 5th term. So my 5th term is going to end up being 40.5. Just kidding, 40.2. I don't know what I was thinking. Okay, so 40.2. And we need to write our rule. So I'll get my chart here. 1, 2, 3, 4, 9, 16.8, 24.6, and 32.4. Okay, this being constant, the very first difference being constant, this is linear. So I'm going to take that change, it's changing by going up 7.8, and I'm going to multiply it, excuse me, 7.8, and I'm going to multiply it by n. And we always start with the first term, so I'm saying n is 1. Well, 1 times 7.8 is 7.8, but I need it to be 9. So to make that 9, I need to add another 1.2. Okay, so then that one does work. So let's try the next one. 7.8 times 2 gets me the second term. Well, 7.8 times 2 is 15.6, but if I add another 1.2 to it, I get 16.8. And that one does go ahead and work if you keep going. And then add don't know why I was adding parentheses. Add 1.2, you do get 24.6. And then 7.8 times 4, add 1.2, and you get 32.4. So to write my rule for the nth term, it's 7.8. What is changing is right here, so that'd be n plus 1.2. And then that will get me my next, or any term in the sequence. All right, so this next one is actually a visual. It is still a sequence. And so we're going to consider each row our n's. So like this is n1, 2, and 3. Okay, so let's draw our chart to kind of go with this. So if I have n, I just said we have 3 of them. And so our AN is how many chairs are at each table. So we have 1 chair, 2, 3, 4, 5, and 6 at the table. So the first one is 6. We count on the next one, and we have 10. And the third set, we have 14. All right, so that's our sequence is really 6, 10, 14. So let's see if we have any differences here. So from 6 to get to 10, I added 4. From 10 to 14, I'm adding 4. So this one's linear. I'm constant in the very first set of differences. So I know my fourth term, because it says find the next term, would be adding 4. So it would be 18. Excuse me, describing the pattern would just say I'm adding 4 chairs each time. Doesn't say anything about the table. We're doing just chairs here. And then I need to write my rule. Well, it's linear, so I know I'm going to take that difference that I'm doing and I'm going to multiply it by n. Okay, so 4 times 1 is 4, but for my very first term, I'm actually wanting 6. So I need to add 2 to that. Then I get 6. Well, let's try that for the second term. So second picture, 4 times 2 is 8, but I want 10, so I'm going to add 2 to that, and I get 10. And then I have 4 times the third n, and that is 12, but I want 14, so I do have to add 4. So to write my rule for the nth term, it's 4 times n plus 2. Like I said, your answers could look different. Some people see these differently, or if you find a Khan Academy video or something that explains this a little bit more to your understanding, you might end up with 2 times parentheses 2n plus 1. It can look different. All in all, it will tend to have the same pattern, however.